Hi students, problem number 14. A point charge of 2 microcoulomb is at the center of a cubical Gaussian surface 9 centimeter on edge. What is the net electric flux through the surface? So you can imagine this is a cubical Gaussian surface. So A, B, C, D is the bottom surface. E, F, G, H is the top surface, so that it forms a closed Gaussian surface which is cubical in shape, whose edge is 9 centimeter. So there is a charge of 2 microcoulomb. It's a positive charge. So this is the charge Q. So it is given as Q is equal to 2 into 10 to the power of minus 6 coulomb. And the medium is assumed to be air or vacuum. Therefore, the permittivity of a free space is taken as what? Epsilon naught is equal to 8.854 into 10 power minus 12. So coulomb square per Newton meter square. So this is coulomb square per Newton meter square. So what is the net electric flux? The total electric flux is asked here. Very simple and a direct question it is. So it may be asked as a multiple choice question even. So this is a 1 mark type of question only. So directly we can apply the Gauss theorem. So from Gauss law, the total or the net electric flux is equal to 1 by epsilon naught times the net charge. So the net charge is equal to one and only charge, that is the 2 microcoulomb. Therefore it is 1 by epsilon naught times the Q. So this is equal to Q by epsilon naught. So this also can be written as what? Q by epsilon naught. So Q is given as 2 microcoulomb, 2 into 10 power minus 6 divided by this value of epsilon naught is 8.854 into 10 power minus 12. So we have to find 2 divided by 8.854. So 2 divided by 8.854. So this is found to be equal to 0.2258. 0.226 into this 10 power minus 12 comes up as plus 12. So into minus 6 will become 10 power 6. So this is 0.226 into 10 power 6, or it can be adjusted that decimal is shifted 2.26 into 10 to the power of 5. Therefore, the net electric flux is equal to 2.26 into 10 to the power of 5, and the unit is Newton meter square per coulomb. So this is the required answer. So the net electric flux is 2.26 into 10 power 5 Newton meter square per coulomb. Very simple and direct numerical problem. I hope you must have understood well. Fine.